So what's the one rule of matrices that we learned yesterday? That's only if you're adding and subtracting. It goes, everything that we do goes rows by columns, right? Okay? That is going to be extra important today because today we are going to be multiplying matrices. Okay. When you multiply matrices, you take the rows of your first matrix and you multiply them by the columns of the second matrix. Rows by columns. Everything we do is rows by columns. Okay? Now, the kicker that's new, because we're multiplying, is, like, let's say I multiplied 3 and 2. What's 3 times 2? 6. What's 2 times 3? 6. Order doesn't matter, right? Right? Okay? 7 times 3 is the same as 3 times 7. Okay? The downfall with matrices is that, and I'm going to put it in nice and big old lettering, is that our order matters. So our order in matrices matters. And here's why. Okay? Yesterday we were doing scalar multiplication. That's where you take a number and you multiply it into the matrix. Okay? That's different than today. Today, the first step that we have to do is we have to determine if we can do the multiplying. So I look at the dimensions of the two matrices that I'm multiplying. You can only multiply two matrices at a time. Okay? So I look at their dimensions. If those middle two numbers are equal, so the kicker is right here. These middle two numbers must be equal. If they're equal, you can multiply. If they are not equal, you can't multiply. It's not possible. The nice thing is that the other two numbers, so I take away those two numbers. The other two numbers are the resultant matrix dimensions. So if I were to multiply those two, a 3 by 2 matrix and a 2 by 1 matrix, in the end, I would get a 3 by 1 matrix answer. Okay? Numbers have to be equal. So you do that first every single time. Okay? So I ask the question, can I multiply those two matrices? Middle two numbers are the same. So my resultant matrix would have dimensions of what? 2 by 5. Can I multiply a 2 by 2 matrix by a 3 by 2 matrix? No. My middle two numbers are not the same. So it is not possible. What if I switched the order? Is that one now possible? Yeah, that's possible now. And the result here would be a 3 by 2.
So can you switch the order, or are you just doing that for the sake of changing up the problem?
Sake of changing up the product. No. If it says do it A times B, you got to do A on the left and B on the right. Okay? So, let's do it. Let's dive right in. Okay? First thing I got to do is I've got to check to see if it's possible or not. What are the dimensions of my left matrix? 3 by 2. Do we agree with 3 by 2? Yep. Dimensions of the right matrix. 2 by 1. So I've got a 3 by 2 times a 2 by 1. Is it possible? Why? Middle numbers are the same. So my result is going to be what size? 3 by 1. Okay? So it's possible. Now, here's how I go about doing this. So I am going to draw myself an oversized 3-row, 1-column matrix. Thinking back to yesterday, the address of this first element is row 1, column 1. Right? The address of this element is row 2. Oops, I almost put row 2, column 2. Row 2. Column 1. Address down here is row 3, column 1. Right? Okay? Now, that's addresses. But it also tells me how I'm going to multiply. What this is saying I'm going to take the first row of the first matrix and I'm going to multiply it by the first column of the second matrix. So that's going to look like, why am I so electric today? Sick of getting shocked. 5 times -2 plus 3 times 3. Then it's going to be the second row times the first column. Second row of the first one times the first column of the second one. Negative 1 times negative 2, and 2 times 3. Then it's going to be the third row of the first one times the first column of the second one. Okay. Now comes the easy part. Now you just got to do the math. 5 times negative 2 is negative 10. Three times 3 is 9. Negative 1 times negative 2 is positive 2. 2 times 3 is 6. Negative 4 times negative 2 is 8. 0 times 3 is 0. So my resultant matrix is negative 1, 8, 8. Zeros are tricky. Anything times 0 is 0. Remember that. Okay? Because you're going to look at this one right here. And you're going to say, that's 8 plus 3. Because you're going to get so focused on trying to get the problem done that you're going to forget the easy stuff. 0 times anything is 0. Okay? Ready to try one on your own? First off, let's see if it works or not. Does it? Dimensions of the first one? Dimensions of the second one? Resulting dimensions. Okay. Because those middle two numbers are the same. Okay, go for it. So this is row 1, column 1. So I'm going to take the first row times the first column. So that's going to be 4 times 5 plus negative 3 times negative 1. Then I'm going to take the first row times the second column. 4 times 0 plus negative 3 times 3. Then I'm going to take the second row times the first column. Second row, first column, gets me 2 times 5. Plus 1 times negative 1. Then I'm going to take the second row times the second column. So that's going to be 2 times 0 plus 1 times 3. 4 times 5 is 20. Negative 3 times negative 1 is positive 3. So that's going to give me 23 in row 1, column 1. 4 times 0 is 0. Negative 3 times positive 3 is negative 9. 2 times 5 is 10. 1 times negative 1 is negative 1. That gives me positive 9. 2 times 0 is 0. 1 times 3 is 3. Yes? Questions? Next one. Try it. Possible, not possible. Possible. Okay, dimensions of the first one, 3 by 1. Dimensions of the second one, 1 by 2. That leaves me with a 3 by 2 result. Row 1, column 1, so that's going to be 5 times 2. Row 1, column 2, so that's going to be 5 times negative 4. Row 2, column 1, so that's going to be 6 times 2. Row 2, column 2, that's going to be 6 times negative 4. Row 3, column 1, and row 3, column 2, that's going to be negative 2 times 2 and negative 2 times 4. 5 times 2 is 10. 5 times negative 4 is negative 20. 6 times 2 is 12. 6 times negative 4 is negative 24. Negative 2 times 2 is negative 4. Negative 2 times 4 is... It should be negative 4 there, shouldn't it?
Yeah.
Yep. So that should be positive 8. Yes, Okay. Try that one. Dimension check. Dimensions of the first one, 2 by 2. Dimensions of the second one. Is it possible? Why not? Middle two numbers are not the same. Yeah, so that one's not possible. All right? Oh, man. Go for it. First off, we got to look at dimensions, right? Okay. Dimensions of A, 2 by 3. Dimensions of B, 3 by 2. Does that make it possible? Yes, and my result is going to be a 2 by 2. Okay, so I make myself a 2 by 2. row 1, column 1. So row 1 is 1 times 6 plus negative 3 times negative 5 plus 7 times 3. Row 1, column 2 is 1 times negative 4 plus negative 3 times 2 plus 7 times 1. Move that bad boy over. I don't think I can now. Oh, look at that, I can. Yes. Row 2, column 1 is going to be negative 1 times 6 plus 2 times negative 5 plus 0 times 3, and negative 1 times negative 4 plus 2 times 2 plus 0 times 1. So that gives me matrix AB here is 6, we'll write that in there. So this is 6 plus 15 plus 21. So that's what, 42? Negative 4 minus 6 plus 7 is negative 3. Negative 6 minus 10 plus 0 is negative 16. Four plus 4 plus 0 is 8. Agree with that one? B times A now. Matrix B is a 3 by 2 matrix. Matrix A is a 2 by 3 matrix. So that result is going to be a 3 by 3 matrix. Yes? See if we can sneak it in here. So, row 1 is going to be 6 times 1 plus negative 4 times negative 1. So now I'm going columns of A. Rows of B, columns of A. 6 times negative 3 plus negative 4 times 2. 6 times 7 plus negative 4 times 0. Row 2 now. Negative 5 times 1 plus 2 times negative 1. Negative 5 times negative 3 plus 2 times 2 negative 5 times 7 plus 2 times 0. Row 3. 3 times 1 plus 1 times negative 1. 3 times negative 3 plus 1 times 2. 3 times 7 plus 1 times 0. So that gives me, let's do a little math in here, 6 plus 4, negative 18 minus 8, 42 plus 0, negative 5 plus negative 2, 15 plus 4, negative 35 plus 0, 3 plus negative 1, negative 9 plus 2, 21 plus 0. So, BA is then going to be 10, negative 26, 42. For some reason the computer is running a little slow. Negative 7, 19, negative 35, 2, negative 7, 21.
Negative 26, 42, negative 7, 19. 2, negative 7, 21. Yes.
Agreed? Okay. Order matters when you're doing matrix multiplication. This is due tomorrow, and I remind you that there is a formative on Friday.